Okay, so in this video, we're going to be practicing P2 questions. So let's begin. So the first part says that ampere, meter, and second are SI base units. Yes, we studied this. State two other SI base units. So this is easy. kg. And what is the fifth one? Kelvin. Kelvin. You can write the full form too. So now they give us an equation, the velocity of electron. So this is meter per second. Moving through a metal conductor is given by the equation this, where E is the charge, F is the force. So first, let's convert it all into base units because we want the base units of U. So force is MA, which is second square kg. So this is the base units of force. Now E is a tricky one, which you probably haven't seen yet. So E is the charge, right? Charge. So the equation relating charge with a base unit with base units is current is equal to charge per unit time, right? Now you don't need to know this equation right now. I'm just telling you this. So the unit of charge is base unit of charge is ampere second, right? Because second and ampere multiply. So charge is ampere per second. So let me just erase all this. So charge is ampere second. Right. Now we are ready to solve this. So let's just begin. Meter per second is equal to, we don't know the unit of mu, so let's just write it mu, kg, meter, second, square. Right. Now, the first thing is this and this cancels out, right? And this and this cancels out, right? So what we are left with is mu is equal to ampere over kg. Oh, I'm sorry, not ampere, kg. Let's just do it like this. So mu times kg second negative 3, because this is not cancelling out. I'm sorry about that. Second negative 3 because it goes up and it gets multiplied by negative 1 divided by ampere is equal to second negative 1. Now, second negative 1 comes here and gets divided. So it becomes second negative square and it gets cancelled out. So mu is equal to ampere second square per kg. So this is the answer. Right? Because what we did next was multiply a here and divide all of this here. And the second goes up and becomes second square. So let's move on. Now, the speed of sound through a gas of pressure P and density rho is given by this equation. So this is velocity and pressure and density. So where K is a constant that has no units. So they have told you that K has no units. And we have done an equation like this in our practice and the constant did not have any units. So this adds up. An experiment is performed to determine the value of K. The data from the experiment is shown. Use the data from figure 1.1 to calculate K. So now to calculate K, we ignore the uncertainty and just plug in the values and calculate K. So first, what we need to do is put the equation in order, right? Put our equation in order, square both sides, which becomes K is equal to V square times rho divided by P, right? This is our equation. Just plug in all these values here. All these values plug in. These are all in standard units, so no need to convert them. Just plug them in here, and we get, okay, I'll just tell you what the equation is. 3.3 times 10 power 2 whole square. This is velocity multiplied by density, which is 1.29. All right. And 9.9 times 10 power 4 Pascal pressure. So the answer comes down to 1.4. K is 1.4. Now on the next one, use your answer in B1, which is the value of K, to determine the value of K with its absolute uncertainty. Right? So we have done this in our practices. So to calculate absolute uncertainties, the long process that you can do is calculate the absolute uncertainty in each value using its percentage, and then calculate the upper bound of K and then subtract the upper bound from the actual value, or calculate the lower bound and subtract the lower bound from the value of K. But what else we can do is just add the uncertainties together. Now the equation was V square, so I'm multiplying, not squaring, that's 3. I'm multiplying it by 2. It's error multiplied by 2, right? Plus the other uncertainties do not have any power, right? So just 2 plus 4. So the percentage uncertainty of K is 12%, right? 12%. Now, what we can do is to find the absolute uncertainty of K. You know the formula. We have done the formula. Absolute uncertainty divided by actual value, I'm just putting a V here, multiplied by 100 is equal to percentage uncertainty, right? So absolute uncertainty is equal to percentage uncertainty divided by 100 multiplied by value, which is 12 divided by 100 multiplied by, what is the value? 1.4. So the absolute uncertainty comes down to, let me just do my calculation. Uh, 0.168. Now, we only had, in the question, we had info in both 2 decimal places, right, and 1 decimal place. So you can choose how you want to answer this. But the first thing is just write 1.4 here, because the value of K was 1.4. Now the uncertainty is this, right? Absolute uncertainty. Now you can write 0.17 here, or you can write 0.2, right? Or you can write 0.2 because the question has given you a 1 decimal place and 2 decimal places, so it's your choice. But I suggest when there's a 2 decimal place, you give your answer in 2 decimal places, right? So let's move on. Now, another equation, the energy E transferred when charge Q moves through an electrical component is given by this equation. V is the potential difference. Use the equation to determine the SI base units of potential difference, right? So basically, the SI base unit of this. So let's just first do the charge. Again, the equation that relates charge with a standard units is I is equal to charge per time. So charge comes down to ampere second. Now, I have written this for the energy here. Now, energy is the same as work done, right? Change in energy is the same as work done. So the SI, to calculate the SI base units of energy, you need to use the work equation, which is F into T. Now, F was kg meter second square multiplied by meter. So the SI base units of energy is this, is kg meter square per second square, right? So let's just write it here, kg meter square. By the way, if you don't know what I said here, is energy is equal to, change of energy is equal to work done. So don't worry about it, right? Just focus on if you have an energy if you have an energy in the equation and you need to find the base units, you just use the work equation, which is F into D. And we'll go into the work equation as well later on in the syllabus. So don't worry about it. Now, just plug in all the base units in the equation. We don't have the base units for V, so just write V times ampere second. Now, V is equal to kg meter square second negative square ampere second, right? So what this becomes is, this second goes up and becomes -1. So -2 plus -1 is -3. So kg meter square second -3 ampere -1, right? So this is our final answer. Let's move on. Now, the diameter of a cylinder is measured as this with an error and with a percentage error given. Calculate the absolute uncertainty. Again, the formula converts to this. I'm not gonna plug in the original formula just because we have done this. So absolute uncertainty becomes 0.0002, right? Now, we have discussed that writing this many zeros is not ideal for us. So we move one position to the left, another position to the left, another position to the left, and this is still not standard. So we move one more position to the left to make it standard, right? So it becomes 2.0. Now, we know that moving to the left means right now the power of 10 is 0. So moving to the left means -1, -1, -1, -1, because we were moving 4 times, right? So this becomes 2 multiplied by 10 raised to power of -4. So this is our uncertainty, right? Don't write too many zeros, guys. Remember to just do this. The cylinder in A stands on a horizontal surface. The pressure exerted on the surface by the cylinder is given by this, right? This is our equation. The measured weight of the cylinder is this, and with error values, calculate the pressure P. So now, to calculate the pressure, we just ignore everything, right? Ignore everything, just, the errors, not everything. Ignore the errors, just put the value of W, which is 0.38, divided by pi times E square, which is 0.0125 whole square. So the pressure becomes, after rounding off, 4x. So the pressure becomes 3096 and some decimal places. I'm just writing four places. Now, in the question, they have given us, in this part, for instance, they have only given us all the values in 2 significant figures. So it's better to write this in 2 significant figures after rounding off, right? And now the absolute uncertainty and the value of P. So again, like we did the last time, just add the uncertainties, percentage uncertainties, and calculate the absolute uncertainty with the formula. So first of all, this has an uncertainty and this has an uncertainty. 2 uncertainties are going to be added. So W has an uncertainty 2.8 plus, now multiply the D uncertainty with 2 because it has a power 2, right? So 2 times 1.6, which comes down to 6%. 6%, right? Now, just a simple formula of percentage uncertainty, absolute uncertainty, which is, again, I'm not going to write the whole formula and derive again. Just going to write this multiplied by the value, which is 3,100, right? So the absolute uncertainty comes down to 186 again, 3 significant figures. So we need to convert them into 2 because in this part, they had only given us 2 significant figures, right? So convert this into 2, so it becomes 190. Moving on. So this is the last question. Length, mass, and temperature are all SI base units. State 2 other SI base units. So this one is again easy. Ampere. Quantities, sorry. This is one more thing to keep in mind. What they are asking, SI base units or quantities, right? So right now they haven't asked us for units. So I can't write ampere. I have to write current, all right? Because that's the quantity. And ampere is its unit. And the next is obviously time. So let's move on. So they have given us another equation. Let's just write it here so it's clear. G is equal to 4 pi square L divided by T square. Now, just ignore the whole question right now and just see this and this, right? So calculate the acceleration of free fall of G. So now we are calculating G. So let's just ignore uncertainties and just plug in the values. 4 pi square times 1.5. Everything is in standard units, so we don't need to convert anything right now. 2.48 square, right? So G comes down to 9.63. Yeah, right, 9.63. So just write 9.63. Yeah, 2 decimal places or 3 significant figures. So you can use 3 significant figures in your answer. So 9.63. Percentage uncertainty in G. Now, this is very easy. Just add the percentage uncertainties. So the percentage uncertainty of L is 2 plus, now the value of T is squared. So just multiply the uncertainty by 2. So this becomes 8%. Now, the next question is calculate the absolute uncertainty using the values in P1 and P2. So basically, absolute uncertainty, again, our formula for absolute uncertainty is 8 divided by 100, percentage uncertainty divided by 100 multiplied by value, which was 9.63. So the absolute uncertainty comes down to, oh, wait a second. Comes down to 0.7704. Now, we can't write this because this has too many significant figures, and we are only allowed to give an answer in 3 significant figures, right? So let's just round this off, and this becomes 0.77. So 77. You can write the 0 if you want or not, but I prefer write it like this right now because 2 decimal places again, 2 decimal places, 2 decimal places. That's why I'm writing it like this. You can also give your answer in 1 significant figure, basically at 1 decimal place, and that's not a problem because there is also 1 significant figure given in the question. So, okay, so this is it for the P2 practice. Now I recommend that you do 5 questions by yourself as well. So, so you'll be fully prepped for your P2, and next we're going to do P1 practice. So thanks for watching. Subscribe to the channel. Goodbye.